Hey there, solution seekers. Ever look at a giant skyscraper and wonder, how on earth did they build that? Or how an elevator just lifts you up? Well, the secret isn't some kind of magic. It's physics. And honestly, it's a lot simpler than you might think. So let's get right into it and explore the amazing world of simple machines and how they let us do things that seem almost impossible. Okay, so here's our game plan. First, we're going to talk about a problem that, trust me, everyone has had. Then, we'll uncover the big secret behind how machines actually work. After that, we'll get to know two of our most important tools. And then, this is the best part, you're getting your own engineering challenge. Finally, we'll connect all of this back to the real world in a huge way. So let's start at the beginning, with a situation I am 100% sure you've been in before. You know the feeling, right? You're staring at a big, heavy box, or maybe trying to move some furniture, and you just know your muscles are not going to do it. You've hit your limit. We've all been in that exact spot, wishing we had just a little bit of a superpower. Well, guess what? For thousands, literally thousands of years, people have been using this really clever trick to solve this exact problem. And it has nothing to do with being stronger. It's all about being smarter with the strength you already have. So, what is this big secret? Let's pull back the curtain and see what's really going on with machines. The secret is the simple machine. It sounds, well, simple, but it's incredibly powerful. All it is a device that helps you use your force more effectively. It can change the direction of your push or pull, or it can change the size, the magnitude of your force. It basically makes you stronger. Think of it as a force multiplier or a force redirector. Okay. Now, this is the most important part, so listen up. Machines do not, I repeat, do not create energy from nothing. That would be magic. You still have to do the work. The machine just takes the energy you give it and uses it way, way better. And this all works because of something called energy transfer. When you push on a lever or pull on a rope, you're literally transferring the energy from your muscles into that machine. The machine then takes that energy and applies it to whatever you're trying to move. It's like a chain reaction, and you're the one who starts it. So, keeping all that in mind, let's open up our engineering toolkit and meet the two stars of today's show, levers and pulleys. On one hand, you've got the lever. Super simple, right? It's just a stiff bar that pivots on a single point. And on the other hand, we have the pulley. That's basically a wheel with a groove in it for a rope. They look totally different, but they both have the same superpower. They make tough jobs easy. The lever is probably one of the oldest tools ever. The absolute classic example is a seesaw. I mean, think about it. You can push down on your end and easily lift up your front on the other side. That pivot point in the middle, the fulcrum, that's what's doing the magic, redirecting your downward push into an upward lift. Pulleys are just awesome. They do two really helpful things. First, they let you pull down to lift something up, and pulling down is a much more natural and easy motion for us. And second, and this is the really cool part, they can actually cut down the amount of effort you need. And this chart shows it all. Look at that. With just one pulley, you're pretty much pulling the full weight of the box. But add a second pulley? Boom! Suddenly, you only need half the effort to lift that exact same box. Now, here's the trade-off. You have to pull the rope twice as far, but you're only using half the force. You're trading a little extra distance for a lot less effort, and that is a fantastic deal. All right, enough theory. Engineering isn't about just knowing things, it's about doing things. So now it's your turn to be the engineer, to become a solution seeker. So here it is, your mission, should you choose to accept it. I want you to design and build a device that can lift a heavy stack of books from the floor up onto a table. You can use a lever, a pulley system, or you could even get really creative and try to combine them. And here's how you're going to tackle this. Step 1, design. Just grab a piece of paper and sketch out your idea. Think about how it's going to work. Step 2, build. Put your machine together. And step 3, my favorite part, test it. See what it can do. How many books can your machine actually lift? And you don't need any fancy equipment for this. Seriously, just look around you. A ruler makes a great lever. A pencil can be your fulcrum. Some string and a bottle cap? That's a perfect pulley right there. Just use what you've got and get creative. Now, I know what you might be thinking. Okay, this is a fun little project, but we're just lifting books. Well, let's zoom out and see how this little project connects to something way, way bigger. Here's the incredible truth. The exact same physics, the same principles you're using to lift a stack of books, are the very same principles that engineers use every single day to build skyscrapers, to design massive bridges, you name it. It all starts right here. Just look at this. Your little ruler and pencil lever, it works on the exact same idea as a giant construction crane that's lifting steel beams that weigh tons. And that string and bottle cap pulley you made, that's the great-great-grandparent of the super complex elevator systems that take us to the top of the tallest buildings in the world. So what this all boils down to is this. It doesn't matter if you want to build roller coasters or design robots or even explore space. You will use these exact concepts. Understanding how to manage force and energy is the absolute bedrock of all engineering. It's that important. So there you have it. You now know the secret that has been powering human creativity and innovation for centuries. The only question is, what are you going to build with it?